On Monday we talked about the definition of a function, and in this section I want to give you an example of a simple linear function, or as what we'll define as being a linear equation. So here's the motivation. A surfboard company has an operating cost of $200 per day and total costs of $3,700 when 20 boards are produced. Assuming that the total cost per day is linearly related to the total number of output of boards, find the equation for costs. So when we read this, we see that there's two important quantities. There's costs, so total cost per day, and there's also the total number of surfboards being produced in that day. And that cost will depend on the number of boards being produced. So let's see if we can come up with a relationship between these two unknowns. A good thing to do is to summarize what's given in a table. So we'll make a little T table in which we'll collect values from our summary. The hardest part of these problems commonly is to determine which is the independent variable and which is the dependent variable. So independent variable is the thing that can be changed. And once that variable is changed, once that value is changed, then the dependent variable's value will also change according to some rules. So in this case, this problem says that the cost per day is related to the number of boards. So if we knew what the number of boards were being produced in a given day, we could find the cost. So number of boards is going to be our x. So let's let x be number of boards. And then the dependent variable, usually our y, will be the cost. So in our table, we're going to summarize what we have by looking at the first sentence and trying to translate it. So a surfboard company has an operating cost of $200 per day. So let's stop there. If they make no boards at all, it costs them $200 a day just to keep the lights on and pay their employees. The second part of that sentence says that there's a total cost of $3,700 per day when 20 boards are produced. So when the number of boards being produced is 20, that costs them $3,700. So now we've taken that information and we've summarized it in this chart. So we have two pieces of information. What that really means is that we have 2 points on the graph of the cost function. We have a point at x equals 0 and y equals 200, that point right there, and a point at x equals 20 and y equals 3,700, so that point right there. And what we would like to do is find the equation for the cost. So we want to be able to find the equation that will connect any number of boards being produced to the value of the cost per day. Now this could be a function that connects these 2 points in that sort of way. It could be a function that goes like this. What we need to know is some more information to tell us how these points are related. So if we go back up and look at our problem, the key word here is linearly related. And that sounds exactly what it means. It means that the way that these 2 points are connected is by a straight line that goes right through those 2 points. So let's talk about how to find the equation of that line. A line is described by knowing 2 points on that line. So let's go give those a name, A and B. So A will be a point with coordinates x1 and y1, and B will be a point with coordinates x2 and y2. So the way we describe a line is similar to how we would describe to a person that's standing at point A how to get to point B. It's almost like the way you'd give a person directions. In order to get from point A to point B, you need to go over a certain distance in the y direction, so up a certain distance, and then you need to turn right and go a certain distance in the x direction. That's how we would describe how to get from point A to point B. The way we do that mathematically is we summarize that ratio, the change in the y over the change in the x, and we call that the slope. So the slope of a line is denoted by m, the letter m, and it's the change in the y values. So this distance here, y2 minus y1, divide by the change in the x values, x2 minus x1. Another way to think about this is a rise over a run. The important part when we calculate, and we'll see here in a moment, is that the y that we use in the very first part of this formula is the same, or corresponds to the same point as the x used in the first part of the bottom. So that these two are both coming from, in our case, point B, and these two are both coming from point A. In other words, we don't want to mix and match them. We don't want to have the y-coordinate of B minus the y-coordinate of A, and then the reverse of the x-coordinate of A minus the x-coordinate of B. That would be incorrect and not consistent. So let's talk about an example. Find the slope of the line through those 2 points. So according to our formula, the slope would equal the change in the y-coordinates. So pick one of the y-coordinates. Usually the second point is a good place to start. So we'll have 3 minus 4, the other y-coordinate, for the first point. And then because we started with 3, we have to start with the same point for the x-coordinate. So 2 minus the x-coordinate of the first point, negative 1. So 3 minus 4 is negative 1, divided by 2 minus a negative 1, so 3. So our slope is negative 1/3. Now if we calculate the slope of a line, let's see if we can describe any point that lies on a line. So let's start with knowing one point on the line. So that's our A. And the way out here maybe is the B that helped us calculate our slope. So let's just assume we know what the slope is. And let's take any point on this line. We call it x comma y. That's the coordinates of this unknown point. Well, the slope from that point to A should be exactly the same as the slope that we found by calculating the slope from A to B. So any 2 points on this line should have the same slope. So let's calculate the slope going from A, which is x1, y1, to the point xy. So it's going to be the difference in the y-coordinates divided by the difference in the x-coordinates. If we multiply both sides of this equation by x1, we have the slope m times x minus x1 equals y minus y1. And that will give us the equation of a line. So given a point on the line and a slope, the equation of a line is, so writing this in the opposite order, is y minus the y-coordinate of the point we know equals the slope times x minus the x-coordinate of the point that we know. This is usually what's called the point-slope formula. And it's usually the most useful equation of a line because it only assumes that we know a point and a slope. And that point can be any point on the line without any sort of special properties. To graph this line, though, it's commonly easier to graph if we solve for y. So if we take this equation and solve for y by adding y1 to the other side, distributing m to both terms, and then collecting the values that don't involve x, so these two right here, we'll call that b. So another way to write the equation of a line is in the form y equals mx plus b. M is still the slope, and b has a special property that it's part of the y-intercept. So the y-intercept of the line is when x equals 0. So x is 0, y will be b, and that number represents the intercept. So if you think of the graph, if we have an equation in this form, we start with our y-intercept. We go from 0 up to the y-intercept at b, and then we take that point there, and then move, according to our slope, our rise over our run, to another point on our line, and then we connect the dots. And that's how we could get the equation of a line, or the graph of a line.